to Recognition of Solids, exercise 24. This is found on page number 245. Question 1. Identify the nets which can be used to form cubes. Now this is a cube. And what is a cube? It is a three-dimensional shape. It can be solid or it can be hollowed, and it has 6 equal squares. Okay, all sides are equal. The length, this is the length, this is the breadth, and this is the height. All sides will be equal in a cube. Now, what is the net of a cube? Now, when you open out a cube, the flat two-dimensional shape that you get, the figure that you get, is called the net of a cube. Now, there are many nets of cubes. Now, all of you must have learned that. Here in this question, we have to identify the nets which can be used to form cubes. Now, there are 5 nets here. Now, which of these can be used to form a cube? Which of these, when you fold it, will form a cube? Right now, they're all flat two-dimensional shapes. Now, when you fold it, you need to get a cube. So you have to visualize that in your mind. You have to see that in your mind. So which of these will help form a cube? Now, remember, they are made up of 6 squares. It's because a cube has 6 faces. It's made up of 6 squares. So 1, 2, 3, 4, 5, 6. But they should be arranged in a particular way, and no square should overlap, should fall on the other one. So visualize that in your mind and see. Now the first one cannot form a cube. Okay, even if you try to put it in different ways, the first one cannot form a cube, whereas the second one can. Now this can be the base. This can come to the back of it. Back of it, this is the base. This is the front, that's the back. Now this is the left, this is the right, and this is the top. So this will form a cube. Now the next one, you can take it in different ways and see whether it forms a cube. Now let's take this as the base or the bottom. So this one will be to its left. This is to its right. Remember, they should go up. They should flip. They should go up. So you have to imagine this in your mind. And this will be the front. Now, when the other sides are taken up, this one to the right will be the top and this one will come to the back. So this will also form a cube. Fourth one will not form a cube because the sides will overlap. Next one, the fifth one, this will form a cube. So here, this will be the base or the bottom. This will be the back. This will be the left. And this will be the front. So imagine all this standing up and you're moving it so that it will form a cube. Then this will be the right side and this will be the top. So this will also form a cube. Question 2. Draw at least 3 different nets for making a cube. Now this is a cube and there are 11 ways in which you can make nets for a cube. But here we're going to do only 3 different nets for cube. So now this one, let's begin with this. This is the base. Take this as a base or the bottom of the cube. Then we have this. Now this will be the back of the cube, which you can see here. Now back means what comes behind there, that is the back of the cube. Then we have the right face here. This is on the right. Then you have this in front. When this is lifted up, this becomes the front. Now this is the one on the left side and this is the one on the top. So if you keep this as the base, lift this up, this becomes the back. Lift this up, this becomes the front. When you lift this up, this becomes the left side. When you lift these two, this part becomes the right and this goes on top to make the cube. This is one way. Now another way is this. Let's begin here. Now here we have a cube here. Let this be the right part. Okay, so we're going to keep this as the right part. Then this is going to be the back. So we're going to lift this up. So when you lift this up, this is the back and this moves to the right side. Then we have the base. This becomes the base or the bottom. This will remain there as it is. Then when you lift this side up, this becomes the left side. Then this becomes the front when you lift this up along with this. and then this goes to the top. So you get a cube. This is the second way of doing it. Now the third way is this is the base or the bottom. Then here we have to the right. Then this becomes the face on the top. You're going to move this to the right, lift this up, it becomes the top, lift it up further and bring it down. This becomes the left side. Then here we have the back. This will become the back and this will become the front. So these are the three different nets for making a cube. Remember, there are 11 different nets. To make a cube, there are 11. We have just drawn 3. Question 3. The dimensions of a cuboid are 6 centimeters, 4 centimeters and 3 centimeters. Draw two different types of oblique sketches for this cuboid. Okay, so here we have a cuboid, and what is a cuboid? It is a shape or a solid. It's a solid with 6 faces. Okay, now when we make it an oblique sketch, we get a shape. Okay, so it has 6 faces which has different values of length, breadth and height. That is a cuboid. So this is known as a cuboid. Now, as you can see, it's a 3D figure, three-dimensional figure. Now, if we have to make an oblique sketch, what we're going to do is show this 3D figure as a 2D shape. So for that, remember the dimensions are these 6 centimeters, 4 centimeters and 3 centimeters. So the length, the longest measurement is taken as the length usually. So this is 6 centimeters. Now we'll make the first one with 6 centimeters as the length and 4 centimeters as the breadth here. So let's write that down here. So this is 6 centimeters and 4 centimeters. So the first thing you have to do is draw a rectangle which is 6 centimeters long with breadth 4 centimeters. Draw a rectangle. Now draw a similar rectangle, one more rectangle just below the first one. Okay, draw one more rectangle just like that. Similarly, 6 centimeters and 4 centimeters. Now join the two ends here. All the ends, you can join the ends. So join there, then join here. Here we have joined and here we have joined. Okay, so we have joined all four. So now can you see it looks like a cuboid. So this is a 3D figure. It looks like a 3D figure now. So in this case, the length is 6 centimeters. Now 4 centimeters is now the height of this cuboid. The height. That means the remaining 3 centimeters will be the width of this cuboid. So let's write 3 centimeters here. So the width of the cuboid is 3 centimeters. The length is 6 centimeters and the height is 4 centimeters. Now the inner part we can show with the help of dotted lines like this. Okay, so draw dotted lines to show the inner part. So now it gives it a more effective look. So this is one type of oblique sketch. Okay, where we have 6 centimeters length, 4 centimeters height and 3 centimeters as the width. Now let's draw one more. So here in this case, this time the length is 6 centimeters. When you draw the rectangle, the length is 6 centimeters and the breadth here is 3 centimeters. Can you see here we did 4 centimeters. Now we are going to make it 3 centimeters. And this rectangle we are going to draw just like this, one more rectangle below this. So we have another rectangle. So this also has 6 centimeters length and 3 centimeters as the width. Now let's join the ends like this. So join the ends. So now you have a 3D shape. It looks like a 3D shape, isn't it? Now inside again put the dotted lines to make it more effective. So we have the dotted lines. So now the length of this cuboid is 6 centimeters. The height is 3 centimeters. Now the width will be 4 centimeters. We have used all the measurements given to us. So this is 4 centimeters. So now in this way we have two different types of oblique sketches for this cuboid. Now, question 4. Two cubes, each with 3 centimeter edge. Now, cube means it will have all sides the same measurement. So, all edges will be 3 centimeters. So, we are taking two cubes. We're going to place them side by side. When you place two cubes side by side, you get a cuboid. So, for this cuboid, first we're going to draw an oblique sketch just like we did the previous one. And then we're going to do an isometric sketch. Now, this is called an isometric paper, dot paper. So on this we will be doing the second one where we take two cubes, we'll place them side to side and then form a cuboid. So let's begin. So first, draw a square. Remember, 3 centimeters is given to us already. So all four sides have 3 centimeters. Draw a square first and then let's write there 3 centimeters. Remember, all the edges are 3 centimeters. All sides of this square are 3 centimeters. Draw one more square just below that. Here also it's all 3 centimeters. And now we're going to join it just like we did earlier. So now we have a cube. So we have a cube this time of all edges 3 centimeters. Now what are they saying? You need to have two cubes and you place them side by side to form a cuboid. That means there should be no gap here. Place it next to it. So let's draw one more square and then one more square just like that, and then join everything all sides now, and now we get this. Okay, so here this time we've made a cuboid. 3 centimeters plus 3 centimeters will make it 6 centimeters. So here now instead of 3 centimeters, what do we have? We have 6 centimeters. The height will be 3 centimeters and the width will also be 3 centimeters. So now we've got an oblique sketch of two cubes which we place side by side, and now we have a cuboid. Can you see now it's become rectangular in shape? So this is a cuboid. And we're going to draw this on this isometric dot paper. So let's begin. So first draw a slanting line along three dots. Okay. Then draw one more slanting line just on the other side of it. Now draw three straight lines, one starting from this edge, one from the middle and one from this end. So we have three. Now join these. Go along the dots and do it. So here we've joined that and we've joined it. Now continue carefully. Draw one there. Now we have a cube. So can you see now we have a cube and all measurements are 3 centimeters. So here we have 3 centimeters. Here we have 3 centimeters. The height is 3 centimeters. Now a figure drawn on an isometric sketch will give you a more better effect than a oblique sketch. Now we need to draw one more to make this a cuboid, isn't it? That's what the question says, draw two cubes. So here we're going to continue. So see the line that has been drawn here. Draw one more line on top, one more line here. So we have three lines like this, and now join the lines. Join that line and this line. So now can you see this has become 6 centimeters. So let's correct that and write it now. So now cuboid, this has become a cuboid. The two cubes together have now formed a cuboid of length 6 centimeters. Height is 3 centimeters and the width is 3 centimeters. So this is the height, this is the width, and this is the length. So we have done this. We have drawn an oblique sketch and we have drawn an isometric sketch. Question 5. The figures given below show shadows of some 3D objects when seen under the lamp of an overhead projector. In each case, name the object. So what you see here are shadows. Shadows of some 3D objects when the light falls on those 3D objects from the top. So which object will give a square as a shadow when light falls on it? It will be a cube. So as you can see, this is the cube here, and like your dice and all that. So if the light falls on top, the shadow will be a square down like this. So the answer is cube. Now the second one is which 3D object will give a rectangular shadow? Okay, so a cuboid, that means like your textbook and all that, like a box. Now when the light falls on top, it will give a rectangular shadow. So this is a cuboid. Then we have a circle. Now, when light falls on which objects will the shadow be a circle? Now, a sphere, like you take a ball, now this is a sphere. Now, the shadow of this will be a circle when light falls on top. Similarly, if it's a cone also, like an ice cream cone, when the light falls on top, it will give a circular shadow. So here the answer is a sphere. Then, which object will give a triangle as its shadow? So here we have a triangular prism. So when light falls on top on this prism, the shadow will be a triangle. So the answer here is prism. 6. Look at the solids drawn below. A few solids are given to us. I will be showing it to you. And looking at that, we have to fill the given chart. So we have a chart here. We have to fill in all these gaps here. So what do we have here? We have polyhedrons. So these are the different polyhedrons: a triangular pyramid, a square pyramid, a hexahedron, and a hexagonal prism. Now we have to write how many faces there are, how many vertices there are, how many edges there are, and this is called the Euler's formula, or you can even pronounce it as the Euler's formula. This will give us the answer 2. So we have to check this to see whether the answer is 2. So let's begin with the first one. So we have the first figure here. This is the triangular pyramid. So the base is a triangle and this is the pyramid here. Now how many faces does it have? Let's count the number of faces. So this is 1, this is 2, this is 3, and we have a fourth one on the other side. So there are 4 faces. Now let's see how many vertices there are. Vertices are the corners. So this is 1, 2, 3, and we have 4. So 4 vertices. So let's write that. So we have 4 vertices. Now the edges. So what are the edges? Now these lines of this triangle that we've drawn first, 1, 2, 3. Then we have this dotted line 4, 5, and 6. So the edges are 6. So we have here 4 faces, 4 vertices, and 6 edges. Now let's form this Euler's formula. Let's see. Faces are 4, edges are 6, and vertices are 4. So plus 4. So now let's work out. 4 plus 4 is 8. 8 minus 6. 8 minus 6 is 2. So we've got this here. Now let's go on to the next figure. Square pyramid. So in the square pyramid, the base is a square. So now let's see how many faces the square pyramid has. So this is the first face. Then this one, this main triangle that we can see here, this main triangle is the second face. Then we can see another triangle here in the side, isn't it? That is the third face. Then back we have another triangle. At the back we have another triangle, so that is the fourth face. And here in this side we have another triangle, and that is the fifth face. So how many faces? There are 5 faces. Now how many vertices does it have? Vertices, remember, are the corners. So this is 1, then 2, 3, 4, 5. So there are 5 vertices. Now how many edges does it have? These are the edges: 1, 2, 3, 4 of the square itself. Then take this line 5, take the next line 6, take the dotted line 7, and take the other line 8. So the edges are 8. Now let's try the Euler's formula. So here, according to this, faces is 5, minus edges is 8, plus the vertices is 5. Now do we get 2? Let's see. 5 plus 5 is 10. 10 minus 8 is 2. Yes, we are getting 2. So in a square pyramid, we've got all our faces, vertices, and edges, and we have followed this, and we've got 2 here. Let's go to the next one, hexahedron. So this is a hexahedron. In the hexahedron, let's see how many faces, vertices, and edges there are. The word hexa itself means 6, so the faces are 6. Now the vertices here, now let's see all the vertices, if we can get them all from this figure. 1, 2, 3, 4, 5, 6, and where? And 2 more on the other side, so that will make it 8 vertices. Now, the most common types of hexahedrons are cubes and cuboids. So if you know the faces, vertices, and edges of a cube, then that should help you write the answer to this question, hexahedron. So now the edges are 12. So we have 12 edges. Let's see if we can try and find the edges. 1, 2, 3, 4. Then this line 5, 6, 7, and 8. On top there are 4. So down also 9, 10, 11, 12. So we have 12 edges. Now let's follow this Euler's formula or the Euler's formula. Now here faces are 6, minus the edges are 12 plus we have the vertices which is 8. Okay, so now 6 plus 8 is 14. 14 minus 12 is 2. So we've got 2 here also. So let's go to the next one. Hexagonal prism. Now this is the figure that you can see here. Now let's count the number of faces. So 1, 2, 3, 4, 5, 6 faces, and one on top 7 and one at the bottom 8. So totally we have 8 faces here. Now vertices, let's count the number of vertices. 1, 2, 3, 4, 5, 6. Then we have 7. Then here in that corner 8, 9, 10, 11 and 12. So our vertices are 12. Now we have to count the edges. So we have 1, 2, 3, 4, 5, 6. 6 are the standing up lines that you can see. Six edges. Now on top here, 7, 8, 9, 10, 11, 12. At the bottom, 13, 14, 15, 16, 17, 18. So the number of edges is 18. So now let's follow this formula now. Faces 8 minus, now edges are 18 plus 12. 8 plus 12 is 20. 20 minus 18 is 2. So here also we've got the answer 2. So can you see we've got the answer 2 everywhere. So this is a hexagonal prism. 8 faces, 12 vertices, 18 edges, and the Euler's formula you get 2. Dies are cubes with dots on each face. Opposite faces of a die always have a total of 7 on them. Now this is a very important point. The opposite faces of a die always have a total of 7. That is, when you add up the opposite faces, it should give you 7. Below are given two nets to make dice. So here we have 1 and 2, two nets of a die, a cube. Okay. The numbers inserted in each square indicate the number of dots in it. So if the number is 2, it's indicating that there are 2 dots there. So instead of putting 2 dots, the number is given as 2. Similarly here, instead of putting 4 dots, it's given as 4. So here, 4 numbers have been given to us. We have to find out what are the 2 numbers here. Similarly here also 3 numbers have been given. We have to find out 3 more. The question is, insert suitable numbers in each blank so that numbers in opposite faces of the die have a total of 7 dots. So we have to put it in such a way that the opposite faces have 7 dots. Now we need to find out which are the opposite faces. When you look at this net and this net, we don't know which the opposite faces are, isn't it? So first we have to find out which are the opposite faces. So let's begin with the first question. So we write down the first question. So you have to remember this part. This is very important. So 1 and 6 together will give you 7. So this is a combination. 1 and 6, 2 and 5 and 3 and 4 because they will add up to give 7. So here we have to find out. Now 6 is there. Now where will 1 come? There or here? It will come in the opposite face. So which face is opposite this face? 6. So that we have to find out. Then what is the number that's going to come here? Which is the face that is opposite to this face? We have to find out. So now these are the opposite faces. So here can you see 1 is opposite to 6. So I've written 1, 2, 3, 4, 5, 6. I've numbered all the faces and 1 is opposite to 6. 2 is opposite to 4 and 3 is opposite to 5. So this is the order for this net. For this net, you start from top 1, 2, 3, 4, 5, 6. Now let's get this question down here and fill in the boxes here. So we have it here. Now remember 1 and 6 are opposite faces. So here we have a number missing and we have 6 here. That means what should come there? 1. So here we have 1. So we have 1 put there in this box. Okay, now here we need a number. Now go back to this and see this is a second box. Now here 2, isn't it? 2 is opposite to 4. So 2 and 4 are here. So this is the combination, these two. So 2 and 4. So 1 and 6 we got here. Now 2 and 4 are opposite each other. So let's see here, this number and this number together should add up to 7. and we already have 4. That means here it is 3. Okay, so we have got our answer here. In the box, we have 1 and 3. Now let's go on to the next one. Now, so this net, again, the order is going to be different. We have to find out which is the face that's coming opposite. So let's do that. Okay, so we have the question here. And we have to remember this. The combination is the first phase. 1 and 6 together will give us 7. 2 and 5. 3 and 4 will give us 7. Now, this is the order for this net. This is the order, starting with 1 down. So 1, 2, 3, 4, 5, 6. And what are the phases that are opposite each other? 1 is opposite to 4. So can you see here? 1 and 4 are opposite each other. 2 is opposite to 5. 2 and 5 are opposite each other. And 3 is opposite to 6. 3 and 6 are opposite. So keeping that in mind, let's work out this. Okay, so here we have 1. 1 is the fifth phase. So 5 is opposite to 2, isn't it? So 1 and this number, isn't it? This is what we are getting. So 1 and this. So 1 and what will give us 7? 1 and 6. So 6 will come here. Now let's take 2 and look at the other net here. So here sixth phase, that and the third one. So 2 will come to this one. So let's draw that for us to get an idea. So 2 and this phase. So 2 and what will give us 7? 2 and 5. 2 plus 5 is 7. So now the other one you can say 1, 2, 3, 4 is missing. So we put 4 here. And you can check this and see 4 and 3 together give us 7. So this is how you have to work out. You have to know which are the opposite faces. And then remember opposite faces will add up to 7. Question 8. The following figures represent nets of some solids. Okay, so all these are nets. That means some solids have been opened out and we've got these nets. Now we have to name the solid. Which solid has given us this net? Which solid has given us this net? Similarly for the other two. Now look at this carefully. There are 1, 2, 3, 4 triangular faces, isn't it? So this is a polyhedron, and since it has 4 triangular faces, this is a tetrahedron or a triangular pyramid. Okay, it's also known as a triangular pyramid. The next one, we can see a triangular base here, isn't it? So this is a triangular prism. The next one, we did a question based on this. So you know this is the net of a cube. And this one, looking at the shape here, you can make out that this is the net of a cuboid. So children, I hope you have understood. With a little bit of practice, by looking at many of these nets and the solids, you will be able to understand this chapter better. So we will stop with this for now. Thank you, children.